Time for example 1. Okay, so in example 1, we were given this function right here, and there is a variable in my numerator. So we're going to use some long division to rewrite this so that it looks like it's in our transformation structure. So I'm going to do the long division over on the side here. So we're going to put 4x, and we're going to put that underneath our division symbol. And I'm going to put x minus 3, which is our divisor, on the outside over here. Okay, so then how many times does x go into 4x? Or another way to express that would just be, what is 4x divided by x? And that's just 4. So I'm going to put a 4 up here. And then I go ahead and do some multiplication. So 4 times x is 4x. Oh, and my pen went a little wonky there. So 4x. And then 4 times negative 3 is negative 12. And then I'm going to go ahead and do some subtraction. Now, these first two terms reduce to 0, which is nice. However, there is nothing over here to subtract from 12. So I'm just going to put plus 0 here as a placeholder. So 0 minus negative 12 is going to give me a positive 12. Now, this is our remainder. And this is our quotient. And this part out here, if you remember, this was our divisor. So remember, we're going to put the remainder over the divisor. So we're going to have an equation that looks like 12 divided by x minus 3, because that's our divisor, and 4 was our quotient, so plus 4. So this is the equation rewritten in transformation form. And this is what we're going to use to answer the questions that follow. So part B is asking us how this equation relates to the parent function of 1 over x. Well, now I can identify how it was shifted, how it was stretched, and all of that fun stuff. So let's go ahead, and I like to write the transformation form right here so that I know what variables I need to look at. Let me zoom out a little bit so I've got a little more room. X minus h plus k. Okay, so the first thing I want to do is look and see what number's in place of a, and I see that that number is 12. So a tells us what our vertical stretch is by, so I can just go ahead and write that. So we've got a vertical stretch of 12. Okay, the next thing I want to do is see what number is in place of h, and I see that that's a 3. So that means I've got a shift, and that means I shifted to the right 3. Shift right 3. And then the last thing I want to do is see what's in place of k, and that number is 4, which means I have a shift where I went up 4. Okay, the next thing that they want us to do is in part C is graph the sketch of g of x. Okay, so when we want to graph, we need to figure out what our vertical asymptotes are and what our horizontal asymptotes are. And what's nice is that we can get that directly from the equation that's been boxed, aka this part right here. Okay, so that shift up of 4, that's going to give us our horizontal asymptote. So this part right here gives us our horizontal asymptote. So I'm going to put a dotted line at y equals negative 4. I mean, positive 4. I don't know why I said negative 4. Okay, here we go. So this has the equation y equals 4. Okay, and then I also want to make a dotted line for our vertical asymptote, which is at 3. So this means I've got a vertical asymptote here at 3. So I'm going to make another dotted line at x equals 3. Here's the equation, x equals 3. Okay, the next thing we need is some points. So I'm going to go ahead and make a table. So x, and I'm going to just leave some room here for my work. Or yeah, I'll just label it. Okay, so then on the right column over here, we're going to put g of x, or which is 12 over x minus 3 plus 4. And I have a feeling I'm going to need a little more room here, so I'm just going to scoot over. Okay. All right, so the next thing I want to do is pick really just some convenient values for me to plot. So I'm going to just go ahead and plot, let's pick 6. So if x equals 6, that means I'm going to put 6 in for x and figure out what that is. So let's see. 6 minus 3 is 3. So I have right here 12 divided by 3, which is 4. 4 plus 4 is going to give me 8. So one of my points is at 6, comma 8. And I'm going to go ahead and plot that. So here's 6. And I'm going to go all the way up to 8. Oh, don't know why that happened. Uh-oh, my screen froze. Give me just one moment. There we go. 6, comma 8. Okay, let's pick another value. I think 9 would work nicely. So that means I'm going to plug 9 in for x. Let's see, 9 minus 3 is 6. So I end up with a statement that looks like 12 divided by 6 plus 4. And 12 divided by 6 is 2. 2 plus 4 is going to give me 6. So another point on my graph is 9 comma 6. So 9 comma 6. Here's that coordinate. Let's pick one more. I have a feeling, and by I have a feeling, I mean I'm just looking at this part right here, and I'm trying to see what numbers I can substitute for x that are nicely divisible by that I can do 12 divided by that number. So I'm going to pick 15, and I do 12 over 15 minus 3 plus 4. So let's see, I end up with 15 minus 3 is 12. So I end up with a statement that looks like 12 divided by 12 plus 4. Well, 12 divided by 12 is just 1. 1 plus 4 is 5. So another point on here is 15 comma 5. And that looks like it's right here. So it looks like one branch of my graph is in that first quadrant right there. And it looks like it's going to get closer to that asymptote of y equals 4, which makes sense. So this part of my graph is going to get really close to that asymptote but never touch. And it looks like the other part of the graph is going to shoot up. Okay, let's pick some points for the other side of my graph. I'm just going to go ahead and pick the value of 2. So that means I'm going to substitute 2 in for x. So 12 divided by, and then 2 minus 3 plus 4. So I end up with 2 minus 3 is going to give me negative 1. So 12 divided by negative 1 is going to be negative 12. Negative 12 plus 4 is going to give me negative 8. So another point is going to be 2 comma negative 8. So there's a point right here. Let's pick another point. Let's pick 0. So let's plug in 0 in for x. 0 minus 3 is negative 3. So 12 divided by negative 3 is negative 4. Negative 4 plus 4 is going to be 0. So it goes through the origin here. Let's pick a third point on that side for good measure. So let's pick negative 3. So I have 12, plug in negative 3 in for x. And I end up with, let's see, negative 3 minus 3 is negative 6. Okay, so I end up with 12 divided by negative 6, which is negative 2. Negative 2 plus 4 is going to be positive 2. So another point is going to be at negative 3, positive 2. And it looks like the other branch of my graph is plotted just like this. And here is a good first sketch of our graph. Now we can also plug in the equation into our graphing calculator or into Desmos just to double check that we've done that. But let's go ahead and try example 2.